fine. Okay, so this term will be what? 0. Okay, plus h1. H1 is what? The height of point 1 from the datum. So you can see that the height, this is small h, okay, and this capital H is this distance. Okay, so this height will be what? Capital H minus h. Are you following what I'm trying to say? Hello? Hello?
Yes, sir.
Yeah. Okay, now again, can someone tell me what will be the pressure at point 2? Can you tell me what will be the pressure at point 2?
Rho G capital H.
No, no, no. Actually, from Pascal's theorem, you already know that the pressure at the same level will always remain same in all, from all direction. Okay, so you can see that whatever will be the
Atmospheric.
pressure here will be exactly equal to the pressure at the liquid when it is exiting. So you can see that this will be also atmospheric pressure. So which means that pressure at this point will also be equal to P naught by rho g. Okay, plus since I have to determine the velocity at point 2, so I will write V square by 2g. Okay, and what will be the h2?
Zero.
What will be h2? What will be h2?
Sir, we are measuring this from this height now, from this datum. Then H2 will be 0.
0. Okay, fine. Now you can see that these two will be cancelled out. Then we will get V square equal to 2g capital H minus h. So V will be square root 2g h minus h. So this will be the velocity. Okay, and if you make the datum from here, then you will get this h will be vomited and this will be minus h. Okay, now what will I do is I will substitute this v into that equation. So that will be a dh and equal to b square root 2g capital H minus h time dt. Okay, now this will be dh divided by square root 2g capital H minus h equal to b divided by a dt. Okay, now integrate both side. Okay, so since it has been started from 0 to te, emptying time. Now what is the initial level of the liquid? If you measure from this, I mean, you have to measure from here. Datum we are taking only for the Bernoulli theorem. Okay, now since we are measuring h from this surface, so you can see that initially small h will be 0 because initially the surface is here, so that's why it will start from 0. Now it has reached at this point, so what will be the h? This will be capital H. Okay, okay, so this will be, take outside 2g. Now it will be h minus h square root divided by 2 0 to h. This will be, suppose it's a circular cross section, then it will be capital D square by small d square. It will be te minus 0. Now it will be 1 divided by square root 2g multiply 2. Now you can see that, okay, one yeah, negative sign will come, right? You can see that the power is negative, no? So negative sign will come because you are integrating with respect to h. So after integrating here, negative sign will come, so that's why negative sign will come. Now when you integrate earlier, initial, I mean finally it will be 0 minus what? Capital H when you substitute the limit. So this will be d square by d square te. Now find te. So te will be d square by d square 2g into 4, take outside here. Okay, now here will be h. that will be the answer. Okay. Oh yeah, actually 1 divided by 2, no, so it will be 1 by 2, so 2 will be here. Okay, so 4 will be here. Okay, so the answer will be d square by d square 2g by capital H. Any problem here? Tell me.
Sir, 1 by 2 now.
No,
G
no,
by 2 A.
no. Actually, I have taken 2 as a 4 because when you absorb this 2 under square root, it will become 4. That's why 4h is coming. Okay, yeah. So here 2 will become g by 2h. Fine. Okay. Any problem?
No, sir.
Yeah. Okay. Okay. So let's move to another topic. That is,
Hello, sir.
yeah.
Sir, previous class PDF is not here, sir, in the link.
Oh, previously, yeah, I will upload it. Don't worry. Today I will do that. Actually, there is an issue of the internet here, so that's why I am not able to do that. Okay. So I will upload that. Don't worry. Okay. Now let's move to the reduction to the variable separable form. Okay. Suppose you have a form like this, dy by dx equal to something like this. Okay, and here a b c are constants. Okay, then what will you do? For that, what will I do is I will take as another variable, that is suppose t. Okay, then what will happen? A plus b dy by dx equal to what? Dt. Dt by dx. Okay, so this kind of substitution you have to do when you face this kind of differential equation. Okay, suppose for example, suppose you have a differential equation of this type, dy by dx equal to sine square x plus 3y plus 5. Okay, so you can easily see that it's not easy, I mean almost it's impossible to separate y as one side and x as another side. So for that, what will I do is I will assume or I will substitute x plus 3y as small t. Then what will happen? Differentiate both sides with respect to x. It will become 1 plus 3 dy by dx equal to dt by dx. And from this you can see dy by dx will be 1 by 3 dt by dx minus 1. Now substitute this into the given differential equation. So at the place of dy by dx, what will I write? 1 by 3 dt by dx minus 1, and this will become sine square t. Okay, t plus 5. Now you will get dt by dx equal to 3 sine square t plus 15, and this minus 1 will become plus 1. So you can see now it's easy to separate. So whole term is a function of t. So you can write 3 sine square t plus 16 equal to dx. Okay, now integrate both sides. It is easy to integrate. So what is the approach to solve this integral? What will
Hello,
you
sir.
do?
Hello.
Yeah.
Hello, sir.
What will be the approach to solve this integral? Tell me. Divide numerator and denominator by sec square t. Okay, sec square t, not divide, multiply, sec square t dt. Okay, then you will see this will become tan square t plus what, 16 sec square t equal to, this will become x plus constant. Okay, now sec square t dt equal to 3 tan square t. Now at the place of sec square t, what I can write, 1 plus tan square t equal to x plus c.
Hello, sir.
Yeah, tell me.
Sir, your voice is not clear, sir. Your voice is not.
Hmm. Actually, I told you, no, I have problem of internet. I'm using my mobile data. But this is visible, right? This one is visible. Is this visible? Is it fine?
Yes, sir.
Okay. So I think this is visible, right? This one, this part is visible. Okay. So this will be 19 tan square t, t plus 16 equal to x plus c. Okay. What will I do? What kind of substitution I will perform here? Tell me. Tell me. Am I audible?
Yes, sir.
Okay. What substitution I will perform? Let tan t equal to u. Then you will see it will become sec square t dt equal to du. Then it will become du divided by 19 u square plus 16 equal to x plus c. Now you can see that this is nothing but the tan inverse x by a. Okay, so you can write 1 by 19 tan inverse 16 by 19 u equal to x plus c. And when you substitute all those variables which we have assumed, then you will get 1 by 19 tan inverse 19 by 4 tan x plus 3y equal to x plus 3y plus c. So this is the solution you will get. Fine or not? Tell me. Again,
Sir, please explain again.
which part? Which part?
So it's 1 by 3 dt by dx minus 1.
1 by?
So it's dy by dx is equal to 1 by 3 dt by dx minus 1.
This one, yes.
Yes, sir. Yes, sir.
I have written, no? Fine?
Yes, thank you, sir.
Yeah. Okay. So this was one problem where you can use the reduction method. Okay. So now we will move to another form that is called homogeneous function. That is also a method of reduction. Okay. So what is the homogeneous? What is the homogeneous function? Can someone tell me? Suppose you have a function something like this. Okay. Now if you substitute x as lambda x, okay, and y as lambda y, and if you get lambda raised to the power n and fxy, any kind of function, if you substitute x as lambda x, y as lambda y, if you get lambda raised to the power n, I mean in any, here n will be order. If you get this kind of function, then this function will be called as a homogeneous function of order n. Of order n. Example. Suppose, I will directly take OD example, okay? Suppose you have differential equation like this. 2xy y dash equal to y square minus x square, okay? So in this case, what will you do? You will do y dash equal to y square minus x square divided by 2xy, okay? Now we have to see whether this is a homogeneous or not. Then what will you do? You will replace x as a lambda x and y as a lambda y. Then you will get fxy equal to lambda square y square lambda square x square divided by 2 lambda square xy. And you can see that this will be lambda square, I mean lambda raised to the power 0, and the same function you will get y square x square divided by 2xy, which means that this is a homogeneous of 0 order, okay? Homogeneous of 0th order, okay? Then what will be the procedure to solve this differential equation, okay? So procedure, what will you do is you will replace y as vx, okay? You will substitute in the differential equation as y equal to vx. Then differentiate this both side with respect to x. You will get y dash v, okay, with respect to x, it will be 1 plus x v dash, okay, x v dash. Now substitute this here. You will get v plus x v dash equal to, what will I write? Y as a vx. You will get v square x square minus x square divided by 2 v x y, okay? Okay, oh yeah, at the place of y also you have to write x. So this is a v. Now you will get v plus x v dash equal to x square, you will see that will be cancelled out. So you will get v square minus 1 divided by 2v. Is it clear up to this point? Tell me. Is it fine?
Yes, sir.
Yeah. Any doubt here? Tell me. Okay. Then what will you do? I will separate. You can see that all variables are separable here. So x v dash equal to v square minus 1 to v, and I will transfer here. You will get v square minus 1 minus 2 v square divided by 2v, and it will be x v dash equal to, this will be minus 1 minus v square divided by 2v. Okay. Okay, so at the place of v dash I will write dv by dx equal to 1 minus minus 1 minus v square divided by 2v. Then this differential equation will become minus dv, I will write like this, minus 2v divided by 1 plus v square dv equal to dx by x. Is it fine? Tell me. Now integrate both sides. You will get v dv divided by 1 plus v square, and clearly you can see it is nothing but ln x plus c. Now substitute again 1 plus v square equal to something like t, then you will get 2v dv equal to dt. Here 2v you can absorb it, then it will become 2v dv. At the place of 2v dv you can write dt divided by t equal to ln x plus c. Again it will become ln t equal to ln x plus c. Now you can substitute every variable. Here you can see that I can also write 1 by t equal to, and you can transfer this ln x here equal to c. Then this will become x by t equal
No,
to
sir, there will be dt by 2 now. There
where
will be dt by 2.
dt, but no, actually I absorbed this.
Yes, sir.
I absorbed this 2v. At the place of 2v dv I have written dt. Fine?
Yes, sir. Yes, sir.
Yeah. Now I will substitute whole. At the place, this x is as it is. Okay. Now at the place of t, what will I write? 1 plus v square. Okay. Equal to c, and again, and here you can see that what it will become, 1 plus v square equal to e raised to the power c, and at the place of e raised to the power c I will write another constant because this is a constant. Okay. Okay, so x divided by 1 plus, and you can see that v is nothing but y by x. Okay, equal to c1. Now you can see this will become x square divided by this will become x square plus y square. Okay, I made some wrong here. I did some mistake. Can you see that? Okay, let me find where I have, if I have made some mistake.
Sir, below there will be x cube.
X cube, yeah, that will be x cube. Okay. Okay, fine. It will become x cube equal to c1. So this another constant, it will become x square plus y square equal to 1 by c1 x cube. Actually I have made some mistake because it should be only x. I think I have made some mistake. Let me find out. At the place of y dash I have written it's correct. It seems correct, no? Okay, the thing is, figure it out. Actually, I have already solved it. I'm not able to find the mistake. Actually, it will be x only. You will see later. I think, where is the mistake? Oh, yeah, this mistake I did. This mistake you can do. You can see that this will be actually 1 by xt, no? 1 divided by xt. This will be 1 by xt. Yeah. This will be 1 divided by x times this. This will be 1 divided by x times this. X times this. Then it will be x square 1 divided by x divided by x square plus y square equal to c1, and that will be x equal to c1 times x square plus y square. Now it will be x square plus y square, and this will be x divided by c1, and suppose 1 by c1 equal to another constant, and this will be x square plus y square, and suppose it's a k, so it will be minus kx equal to 0. Can someone tell me what is this equation? Which curve? This equation represents which curve? This equation represents which curve? Am I audible? Hello? Am I audible or not? This is actually equation of circle. Equation of circle. Okay? And the center is at tell me
k comma 0.
k comma 0. What is the radius? What is the radius? R equal to k only. And this is nothing but this kind of curves. Since k is a parameter, okay, you can clearly see that k is a parameter. It can be negative and positive both. So this kind of family of circle you will see. Okay. So center, you can clearly see that k comma 0, or you can also see if k is negative, so here and radius will be k. Okay, fine. Now let's move forward. Here radius will be modulus of k, because if k is negative then it will be radius, because it's a square root. Okay, so that's why you will get mod of x. So this is the one kind of problem you will see. Now let's move to another problem, exactness of the differential equation. Exact differential equation. Differential equation. And in exact differential equation you will always see this kind of form, m dx plus n dy equal to 0. Okay, I'm not saying that whether it is exact or not, but if you see this kind of problem, then how you will approach it? Tell me, how you will approach it?
So partially differentiating m with the other one dy and partially differentiating n with the dx.
Okay, fine, it's correct. But yeah, but I will start from very fundamental. Okay, suppose a function, of form u x y. Okay, u x y equal to 0. Actually it is an equation, but I'm still saying this if it is a function. Okay, now what I will do is I will differentiate this function u, then you will get du equal to del u by del x dx plus del u by del y dy. Okay, and since not exactly 0, it can be any kind of constant. Okay, any kind of constant. So when you differentiate both, not differentiation, it is actually called differential. It is called differential. Okay, so if you take the differential both side, then you will get, by the chain rule, you will get this and it will become 0. Then you will get this kind of form where it will be m dx plus n dy equal to 0. Okay, where m is du by del u by del x and n is del u by del y. Okay, now from the definition of exactness you can see what will I do is I will differentiate this equation with respect to y. Then you can see that it will become del square u del y del x. Okay, suppose it's equation number 1. Again I will do partial differential in this equation but with respect to x, then it will become this. Then you will get del square u del x del y. This is equation number 2. You can clearly see that from the property of the partial differentiation we can see that del u by del y del x will be exactly equal to del u by del x del y. Then I can say that del m by del y equal to del n by del x. This is called condition. This is called necessary and sufficient condition. For exactness of function u x y equal to c. Okay, so which means that if you want to solve this kind of differential equation and if you want to get the solution like this, then the differential equation must be exact. And what is the condition of the exactness? This. Okay. Now the thing is how you will solve it. Okay. So let's solve this. Okay. What is the approach? Tell me. I know that from earlier, I know that m equal to del u by del x. Okay. Because at the place of m only, I have assumed it is del u by del x. And you have to solve for u. You have to solve for u. Then what will you do? You will write like this. Okay. Integrate both sides. Since you can see that it is actually partial integral, which means that here m can be a function of x and y both. Okay. But I will integrate with respect to x only. So you will get u equal to integral m del x plus this will be a function of y. Okay. Because it is a partial integral with respect to x. You can clearly see that when you differentiate with respect to x, this will be gone. Okay. So that's why it can be a function of y or just a constant, but it cannot be a function of x. Okay. This is a equation number 1. Okay. Now I already know that n equal to what? Del u by del y. Okay. So again I have to satisfy this equation also. You already got u, you already got the function u, but still I don't know what is fy. Okay. So to get fy I will use this. So you have to differentiate u, this equation with respect to y partially. Okay. Then we don't know. What will I do? I will write like this. Okay. Now you can see that it is a differential with respect to y. So what will I write? Del dy. Okay. Del f by, no, I mean it's just a function of y, so I can clearly write del f by del y. Okay. So del u by del y what? N equal to del y m del x plus del f by del y. Okay. I need what? I need f. I need what? F. So multiply both side by del y. You will get del f equal to n del y. Okay. Plus you can see that this del y will be cancelled out. It will become del only m del x. Okay. Now integrate it. You will get f equal to n del y plus this will be gone. So it will become only m del x. Okay. Now substitute this into this. You will substitute this here. Then finally, after simplifying all terms, you will get a solution like in integral form, and that solution will be something like m, okay, dx plus n dy equal to c. But there is a condition. What is that condition? This this integral must be solved with respect to x, or you can say that by taking y as a constant, okay. And this integral has to be solved such that by taking n independent of x, by taking n terms independent of x. So this is the solution when you want to solve an exact form of differential equation. Is there any doubt here? Tell me. Am I audible?
Yes, sir.
Yeah. Okay. You just work on it. When you go your home, just work on it, then you will get, this is the conclusion or this is the result you will get. Let's solve one problem, then you will get the idea, you will have one idea. Okay, suppose you have a differential equation cos x plus y, okay, dx, okay, plus 3y square plus 2y plus cos x plus y dy equal to 0. I will solve by two methods. Okay, first I will solve by fundamental whatever I derived. Okay, then I will solve directly using this formula. Then this is what, this is nothing but del m by del x. Okay, so you can see that not del m by del x, del u by del x, right? This is the del u by del x. Okay, del u by del x, and this term is what, del u by del y. So what will I do is, you can see that here del u by del x is what, cos x plus y. Okay, now we can write del u equal to cos x plus y del x, integrate both side, then you will get u equal to, since you can see I have to integrate with respect to x, okay, so it will become sine x plus y plus function of y. Okay, since you are integrating with respect to x, then one constant but not a constant, it's a partial integral, then that integral, the integrating constant will come as a function of y. So take first equation. Now what we have, another equation del u by del y. So first I will differentiate this equation with respect to y. Okay, then you can see it will become cos x plus y. Okay, other will be constant, other will be 0, plus this will be what, del f by del y. Since we know that this is nothing but this, so what you have, 3y square plus 2y plus cos x plus y. Okay, clearly you can see that this term will be cancelled out. You will get del f by del y equal to 3y square plus 2y. Okay, since then now you can write 3y square plus 2y del y, integrate both sides. So you can clearly see that all are function of y only. Okay, so f will be y cube plus y square. Now this will be a simple constant independent of x and y. Okay, now substitute this directly here, so you will get u equal to sine x plus y plus like this, y cube plus y square plus c. This is the solution. Okay, now you can directly use that formula. Okay, what is that formula? This is the first method and this is the second method. This is the first, this is the second. What is that formula? The formula is saying that m, you have to integrate m, this is the m, so that is cos x plus y d del x, I mean dx you can write. Okay, plus n, terms of n which are independent of x, terms of n which are independent of x. Okay, whatever I wrote here, terms of n which are independent of x. Okay, so you can see that only these two terms in n which are independent of x, this is not independent of x. So what will I do? Directly write 3y square plus 2y, 3y square plus 2y dy equal to c. It's a clear. Okay, you can see that. And one more thing, I have to integrate this by taking y as a constant, so clearly sine x plus y, and this will be what, y cube plus y square equal to c. Same solution you are getting. Now you will say, sir, here we are getting u equal to this, but I know that I am solving u equal to c problem. Okay, so this is nothing but c. I mean the solution will be this equal to c. Okay, and here also you are getting the same solution. Is there any problem? Fine or not?
So the C is actually U.
What?
Why we are taking that U equal to C?
That is the property of exact, because you are finding u function. Actually, you are solving for u. This equation is nothing but, this differential equation is nothing but a differential of equation this. This differential equation is nothing but the differential of this function. And what is that? uxy equal to c. When you take the differential, so you will get this kind of form equal to 0, and that takes the form m dx equal to n dy. Okay, so after solving you will get u equal to what? U equal to this. And what is u? U is this, and what you are solving for? U equal to c, which means that this equal to c. So I meant to say this is u. This is u which are looking for. Okay, and that is equal to what? C. That is constant. The same thing you are getting this. This is nothing but u which you are looking for. Fine?
Okay, sir.
When you take
Yes,
the
yes.
differential, you will get the differential equation. When you take the differential by using the chain rule, you will get your differential equation. This is the u which you are looking for. Fine?
Yes, sir.
Any
So,
doubt? Yeah.
how this is relating to that when in thermodynamics we actually take the PV equal to nRT as a exact equation.
Say me again.
I mean, in thermodynamics we actually following this exact equation for PV equal to nRT, isn't it?
Then?
So, how that is these two are related? I mean, a function need to be equal to a constant. If a function is equal to a constant value, then it can be termed as exact.
I mean, yeah, it's a general form. I mean, there are lots of application here. I mean, when you solve Cauchy-Riemann equation in complex variable, there also, I mean, you will solve this kind of differential equation. There are lots of application. Not here, not just here. There are lots of application. This is the mathematics, and you have to apply everywhere. Fine?
Yes, sir.
Now let's take another case. What if the differential equation is not exact? Okay? Non-exact OD. In this case, you will find integrating factor. Okay? Suppose you have the same form, right? M dx plus n dy equal to 0. Okay, so this is the differential equation, but this time del m by del y is not equal to del n by del x. Okay, then what will you do? I will multiply this differential equation by an integrating factor. Okay, multiply both sides by integrating factor, and I will name it as a p. Okay, both sides. I have the advantage. I can multiply both sides since it is an equation. Okay, and I am saying that this is the integrating factor, and if I multiply this by p, then it becomes exact. Okay, I'm just assuming that. Suppose I'm multiplying this differential equation by p, and if it is exact, then what is the condition for P? That's what I am trying to derive. Let's multiply both sides this equation by P. Then you will get Pm dx plus Pn dy equal to 0. I can multiply, right? Now I am saying that assume del Pm by del y equal to del Pn by del x. Okay, assuming this differential equation is exact, which means that I can write this. Okay, now what is the condition? I will get Py m, I will use the product rule, Py m plus Pmy. Py is subscript, which means that I am differentiating P with respect to y. Okay, similarly I will write Pxn plus Pnx. Okay, so this is the condition. Now we have two different cases. Okay, case 1, if P is only a function of x. I'm assuming if P is only a function of x, which means that if I am assuming that our integrating factor is just a function of x, then what will happen? This term will be 0. Then I will write Pmy and I can write Pxn plus Pnx. Okay, now subtract this, you will get Pxn equal to P times Nx. Oh, you will get P times My minus Nx. Okay, and Px is what? Del P by del x equal to P 1 by n, and My is what? Del My del y minus Nx is what? Del n by del x. Okay, now I can write del P by del P, del P by P, and n del m by del y minus del n by del x. Okay, integrate both sides, you will get ln P equal to 1 by n del m by del y minus del n by del x. Okay, I can also write P equal to e raised to the power 1 by n del m by del y minus del n by del x. This is the form of P, and this is nothing but the integrating factor. But there is a condition. Condition is what? P is only a function of x. Okay, this is the case 1. Okay, where you are assuming that our integrating factor is only a function of x. Okay, and what if case 2? If P is a function of y, then what will happen? In that case, you will see that this term will become 0. This term will become 0, and in that case you will get P equal to e raised to the power 1 divided by m. Okay, and negative, this will be reversed. This is the situation when P will be a function of y. There is another situation when P is a function of x and y. Okay, but that thing is out of your scope, so that's why I will not discuss that. Okay, so let's take one application. One application is what? First order ODE, first order linear ODE. And what is that? this is a very famous dy by dx plus k y equal to q, right? Are you aware of this? This is the first order linear ODE. Okay, are you following what I'm trying to say? Just say me yes or no.
Yes, sir.
Okay, now I will try to convert this into m dx and n dy. Okay, then you will see dy equal to ky dx equal to q dx. Take dx as a common, you will get ky minus q. Okay, dx plus dy equal to 0. You can see that this is m and here 1, so that is n. Okay, now I'm assuming that our integrating factor is a function of x, is a function of x. Okay, then what will be our integrating factor? That is p equal to integrating factor, that will be e raised to the power what, 1 by m, 1 by m or n, 1 by n. So here it is 1 by n equal to 1. Okay, now that is del m by del y, del m by del y, you can see that it is k only. Okay, minus del n by del x, that will be 0. Okay, del x. Okay, so p will be e raised to the power k dx. Okay, this is your integrating, it's a very famous. Okay, now substitute, I mean everything is done. Okay, now what I have to write? I have to write the solution. What is the solution? pm dx plus pn dy equal to 0. This is the solution of the exact form, and here I have to differentiate what, taking y as a constant, taking y constant, and this I have to integrate taking n terms which are independent of x, which are independent of x. Okay, so what is p? P, which you already got, this is k dx. What is m? M is ky minus q. Plus p, p is already we got k dx, and taking, I mean this is the whole term, right? This is n is what, this is n, right? This is, yeah, this is 1. You can see that these terms are this term. Okay, what is n? N is 1, right? So yeah, so you can see that these terms are actually not independent of x. This term is not exactly independent of x, so this will be 0, right? This whole term is not independent of x, that's why it will be 0. Okay, now this will be what, k e k dx. Okay, dx minus e k dx q dx equal to 0. This will be what, tell me what is this? Is a constant, right? And when you integrate it, what it will become? Tell me. Tell me. This is the integrating factor, right? When you integrate it, it will become integrating factor divided by k. Okay, tell me. Okay, y is missing here. Okay, yeah, y is missing here. Now it is integrating factor k, and this will be what, y equal to, you can see, now this is what, integrating factor times y integrating factor q dx. This is the derivation which you usually apply. Any doubt? Why you guys are so silent? Tell me. Are you following?
Yes, sir.
So this is the solution of the first order linear differential equation. Okay, I mean, forget about all the derivation, just understand what I told you, but anyhow you have to remember this. Okay, okay,
So,
let's, yeah.
so can we arrive at a conclusion that the first order linear differential equation will be non-exact?
Yeah, exactly. First order linear differential equation is what? Not exact. That's why you have to multiply with the integrating factor, and this is the integrating factor. That's why we have to find the integrating factor. This is the integrating factor. Okay, okay, let's take one example. What is that? E x plus y plus y e y dx plus x e to the power y minus 1 dy equal to 0. First we have to find, since you can see that del m by del y is what? E raised to the power x plus y plus e raised to the power y plus y e raised to the power y, and del n by del x equal to what? Just e raised to the power y. So clearly del m by del y is not equal to del n by del x. Okay, so what will I do? I will find integrating factor, and what is that? E raised to the power 1 by m. I will take the second condition. Then what it will be? Del n by del x minus del m by del y. What was that? Del y. Okay, so what is m? M is exactly e raised to the power x plus y plus y e raised to the power y, and you can see that del n by del x is e raised to the power y minus e raised to the power x plus y plus e raised to the power y plus y e raised to the power y del y. You can see that this term will be cancelled out, and by taking minus 1 common, you will see the numerator and denominator is exactly same. So that will be what? 1 del y. So it will be e raised to the power minus y. This is your integrating factor. Now multiply this and get the solution. And what is the solution? E raised to the power minus y, m. M is what? E x plus y plus y e y dx plus e raised to the power minus y and x e raised to the power y minus 1. Okay, now when you take inside, you will get e raised to the power x plus y dx. In this term, when you take the inside, you will get this, and in this term, when you take inside, you will get at x minus e raised to the power minus y dy equal to 0. Since I have to integrate this by taking y as a constant, so you will get e raised to the power x plus xy, and you have to integrate this by taking those terms of n which are independent of x. Okay, so independent of x terms are only this. Okay, so you will get minus, okay, and this will be e raised to the power minus y minus 1 equal to c. So this will be cancelled out. You will get e raised to the power x plus e raised to the power minus y plus xy equal to c. This is the solution. Fine or not? Tell me. Any problem?
No, sir.
No, sir.
Is everything clear?
Yes, sir.
Okay, so let's move to another form, that is Bernoulli's equation. Okay, so Bernoulli's equation says dy by dx plus py equal to qy raised to the power n. If this is the form, then we can say that this is a Bernoulli's equation. So to solve this, what will I do? I will divide both sides by y raised to the power n. So you will get y raised to the power minus n dy by dx plus p y raised to the power 1 minus n equal to q. Okay. Now take y raised to the power 1
Yes,
minus
sir.
n equal to
Your
u.
voice is not coming, sir.
Not coming. Again same internet issue. Let's wait for a minute. Fine. Am I audible? Okay, fine. Up to this point, it's fine, right? Just say me yes or no.
No,
Sir,
sir.
can you repeat, sir? Sir, can you repeat, sir? Bernoulli's equation.
Okay, this is the Bernoulli's equation, right? This is a very standard form of Bernoulli equation. So to solve this, what will I do? I will divide this whole differential equation by y raised to the power n. So you will get this. Fine. Now I will use the substitution. And what will I substitute this? I will take y raised to the power 1 minus n as u. Fine. Tell me yes or no.
Yes, sir.
Yeah. Okay. Take the derivative with respect to x. So you will get 1 minus n. 1 minus n dy by dx equal to du by dx. Okay. Then, oh yeah. So this will be y raised to the power minus n also. Okay. So this will be y raised to the power minus n dy by dx equal to 1 divided by 1 minus n du by dx. Substitute this into this. So you will get 1 divided by 1 minus n du by dx plus pu equal to q. This will be du by dx plus p 1 minus n u q 1 minus n. This is a standard first order linear differential equation. So what will be the integrating factor? E raised to the power this whole as a p, or you can say in our terms it is a k. So this will be p times 1 minus n dx. Okay, so you will get what? E raised to the power p1 minus n x. Fine? No, it's not correct, because we don't know what is the p. P can be a function of x also, so this will be p dx. Okay, now substitute the whole term as like this. So integrating factor, this will be e1 minus n p dx, and u equal to e1 minus n p dx times q, and q is what? Q times 1 minus n dx. So now you can see that this is your solution. Okay, so 1 minus n p dx, and at the place of u, what you have to write? U raised to the power 1 minus n, y raised to the power 1 minus n, q1 minus n dx. So this is the solution. Okay, it depends on what kind of differential equation you are taking. Fine? Yes or no? Am I audible?
Yes, sir.
Yes, sir.
Yes, sir.
Should I move further?
Yes, sir.
Yeah. Okay. So yeah, I will discuss two more cases, and that's it. First order differential equation is done. Then in the next class, I will talk about second order differential equation. Okay. So there is another case that is reducible to homogeneous. And what is that? Suppose you have a differential equation of this form, dy by dx equal to function of ax plus by plus c divided by dx plus cy plus f. Okay, so the thing is, this is the differential equation. Now I want to reduce into the homogeneous form. Can you tell me whether this equation is in the homogeneous form or not? Tell me.
Not homogeneous.
Not homogeneous. Why? What is the problem? What is the issue?
So-called.
Huh?
We are not able to get lambda to the power
Yes.
from this function.
And that problem is occurring because here C and F are there. If suppose C and F are 0, then this is a standard homogeneous form. Okay, so for that, what will I do? I will substitute x as a capital X plus h, and y as a capital Y plus k. Okay, then you will see that this function will be x plus h plus b, y plus k plus c, and this will be d x plus h plus c, y plus k plus d, and this will be something like ax plus by plus ah plus bk plus c, and this will be dx plus cy plus dh plus ck plus f. This is f. Okay. Now what will I do? I will make these two equation as 0. I will make these two equation as 0 and I will solve for what? H and K. Since you can see A, B, C, D, A, B, C, D, E. It is E. E. Okay. You can see that A, B, D, E, C and F are constants, and that you will get from the differential equation, but here H, K are variable. So what I am trying to do is I will make this remaining residual, this is a residual, as a 0. Then you can see that this whole expression will become homogeneous. Okay, and I will make this as constraint. Okay. Okay, so and then I will solve for H and K, and later I will substitute H and K value in the differential equation. Let's take one example, then you will get to know. Suppose I have a differential equation dy by dx is something like 2y minus x minus 4 divided by y minus 3x plus 3. What will I do? I will do x as a capital X plus h, y as a capital Y plus k. Substitute that. And also you will see that here dx is nothing but capital Dx and dy is nothing but capital dy. Then I can also write dy by dx as a capital dy by capital dx. And since I am replacing y as a capital Y plus k, x as a capital X plus h minus 4 divided by y as a Y plus k minus 3 x plus h plus 3. Then you will get dy by dx as 2y minus x plus 2k minus h minus 4 divided by y minus 3x plus k minus 3h plus 9. And I am saying that I will make these two equations as a 0. 2k minus h minus 4 as a 0, k minus 3h plus 9 as a 0. Constraint. Solve for h and k. You will get h as what? You will see, you will get h as 2 and k equal to 3. You will get, it will satisfy 4 minus 3, no sorry, 6 to 4, right? And here also 3 minus 6, yeah. It's not satisfying, no? Maybe I'm making some mistake. 2y minus x, 2k minus h minus 4, y 3x, k minus 3h plus 3. It will be 3, no? This is 3. Now it should satisfy. 3, yeah, 3 minus 6, yeah, now it's satisfying. Okay, so dy by dx, since I am substituting this as 0, I have solved already, so you will get 2y minus x divided by y minus 3x. Now it is a homogeneous form. It's clear or not? Tell me yes or no.
Yes, sir.
Okay.
Yes, sir.
Now what will I do? I will substitute y as a vx, or yeah, y as a vx. Then you will get dy by dx equal to v plus v dash x, right? V plus v dash x, yeah, or dv by dx. Just write dv by dx, x times dv by dx. Substitute here v plus x dv by dx equal to 2. This will become 2vx, and from everywhere v will be cancelled out. I mean x will be cancelled out. You will get 2v minus 1 v minus 3. Okay, then you will get x dv by dx 2v minus 1 minus 2v minus 1 minus v plus 3, then v minus 3. This will be v plus 2, and this will be v minus 3. Then it will be v minus 3 divided by v plus 2 dv equal to dx by x. Now you have to integrate it. Any problem? I made one mistake. So when you multiply this, when you transfer this v, it will become v square, and it will be 3v. Fine? Tell me. Now you are enough mature to solve this differential, I mean this integral. It's fine or not? Then suppose you get something like this. I'm just saying, if you get something like this, then at the place of x, what you will write? Capital X, x minus h. You will write x minus, at the place of capital X, you will write small x minus h. You already got. What is h? 2. Okay, and at the place of v, what you will write? Y by x, capital Y by capital X plus c, then x minus 2, and capital Y is what? Y minus k, small y minus k, small y minus what is k? K you already got, 3, and small x minus 2 plus c. So this is the solution. I will solve this. Actually, I have not solved this problem. I will solve this integral. I will use the calculator. Is my screen visible? Tell me.
Yes, sir.
Is my
Yes,
screen
sir.
visible? Yeah. So you have this solution. It's a very lengthy solution because you have to break. First you have to take this, then you have to apply that partial fraction, then you have to make a square, then you have to apply the integral formula. Yeah, it's very lengthy, but yeah, I mean, you learned how you can solve this. Okay, so yeah, that's why I didn't solve this. It's a lengthy. Okay, fine. This was the last problem I wanted to solve. Fine, today's lecture is over.
Yes, sir.
Yeah, any problem? From the next lecture, I will introduce second order differential equation. Okay, then after that I will start Laplace, and using the Laplace you can also solve some differential equation, some complicated second order differential equation. Fine?
Yes, sir.
Yeah. Okay, see you. See you next lecture.
Thank you.
Any doubt? Any
Thank you,
problem?
sir.